slide right here, it has all of those definitions we talked about last time. So as you move throughout this unit, as you move throughout the year, right, this stuff that we talked about last time, all of this we bring up every single unit. So if you're ever at a point where you're like, I don't know how I express my increasing or decreasing, right? You can come here and be like, oh, it's my interval notation with my x values. Remember, extremist, order pairs, your end behavior, all this stuff. So you don't need to write this down. I just want to point it out there that it's on those slides for you as like a good reference when you might need it. Do you have those slides? Love that question. Yes. Where are they located? Schoology. You also have the slides from last time. I went through and I have all my filled in work on those slides. So as you are preparing for your quiz on the 5th, you might want to go back and be like, try some problems again. And if you want, you can kind of check back through with my work to like see if you're getting it, whatever you need to do. Also, remember, if you miss a class and you want to go through those notes, you can just kind of go through the filled in, or if you want to hear it, there's a recording too. But we're going to get into our more like, more fun, more funky functions for today versus last time.
Why is it curved?
I don't know. That's a great question. So why don't you guys take a minute, show a few at your table. What are you noticing that's similar or different between these two? All right, guys. Yes. Just take the pass and do e-help pass too. All right, guys. So bring it back together. So, anybody want to share something that they see between those two graphs? Maybe similar, maybe something that's different. No wrong answers. It's just whatever you're noticing. Anyway, what is your observation, Jaden?
One looks like an S and one looks like an R.
Okay, I actually love that. R for it's a root. So my R function, we have, we talked about a U last time. We talked about a V. So this is our R.
And then
and
S,
this is our,
it sounds like C.
what?
S.
See what you got there. Maybe, I don't know. So this is, why do you think maybe our square root can't go all the way? What do you think, Malcolm?
Square roots can't be negative, but cube roots can, so it goes into the negative while the square root doesn't.
Awesome. I can take a cube root of a negative, right? Like I could get the cube root over here of -8 and it would be, my output would be -2. Could I take the square root of -4 right here?
No.
No, so notice there's not a fully graph here, meaning what is going to kind of be restricted? Those values you could take the square root of, meaning,
Domain.
yes, my domain's going to be restricted here versus my cube root's domain could kind of go on in both directions. So that's going to be the big difference between my square root and my cube root here. Where it's not giving us real values. So something fun to look forward to is in a couple months you will do square roots of negative values. But for right now, it's just not giving us anything real. So let's look through some examples of these radical functions. That is the parent function for those two. So why don't you guys take 2 minutes and jot down what you can. If you're stuck on something, just skip it and go to what you feel good about. We're going to go through all of them together. But just take 2 minutes to at least think on your own first. All right, everybody. Let's see what you guys are thinking. If you haven't got through all of it, it's okay. We're going to kind of go through it together. And let's hear from you guys in the front middle table. What are you thinking for the domain? So, sorry, I forgot to preface it. As the functions get a little crazier, still stick to your roots, meaning how did you find domain? It was along your x, which meant you looked from where to where? Along the x means you're going to look from left to right. So if you go from the left to the right, think about where you start and then where you go to. So now what are you guys thinking for the domain?
1 to infinity.
Good job. So from 1 to infinity, infinity always in parentheses. What about with 1? Would that be a bracket? Good, you do include it. I have a question for you guys. Can you distinguish the difference between a bracket and a parenthesis here for me? Like, do you see this is a bracket, this is a parenthesis? Cool. I'm very self-aware. I don't have the best handwriting. I know that is one of my areas of growth as a teacher, but I will say that as a student, if I can't see or read the difference between a bracket or a parenthesis for you guys, like on your quiz on the 5th, that is just going to be marked wrong. So make sure if you want something to be a square bracket, square it up. If you want it to be a parenthesis, curved. Someone every year does a curvy squarey bracket situation, and it's just a curvy squarey bracket, you know.
Are our quizzes for this class on paper?
Yeah. Every quiz test is on paper, and there's no calculator for the first unit. I think I said that a couple times, but you guys see why, right? Like, this is what we're doing. You're not like really needing to calculate anything. So, range. Let's hear from you guys up here. What are you thinking for the range? What do you think, Jaden?
-3 to infinity.
Great job.
Bracket at -3.
Yeah, good. Bracket, -3 to infinity, parentheses. And then you guys in that back table near the door, were we increasing or decreasing? Yeah, good. So you have nothing or on your decreasing interval. And if you're increasing the whole time, think about where is your increasing starting?
1.
-3.
1 is on the x, right? So kind of think always on my x. So from 1 to infinity. And increasing means I should always have
Parentheses.
Yeah, good. So remember increasing, decreasing. On your x, always parentheses. Intercepts. Let's hear from you guys near my desk. What intercepts do you see?
10, 0.
Great. And extremas. So we talked last time about extremas being those peaks or those valleys. A peak meaning you're going from like increasing to decreasing, peak. Valley meaning decreasing to increasing. So here, noticing how you were only increasing the whole time. So did I ever like have a moment where I was like changing that direction? No. So this point right here is not going to be an extrema based off of that definition. You are just going to use your extremas as like a peak or a valley.
Why not that?
Why not that? Because extrema, what we just said, when you're changing a direction. Noticing here we're only increasing. So, kind of think about those peaks and the valleys. What do we think? Was this continuous, yes or no?
Yes.
Yes. And we switched it up down here. We wanted to find f of x equals -1. What does f of x represent?
Y.
Yes. So this means my y value is -1. So basically, if I know y, I'm trying to find the opposite, which means my x. Anybody have an idea what is our x value when y is -1? What do you see, Yusra? You got it. So I go to when y is -1. I go across to my graph. Boom, it's here. X is 5. What about as x approaches -infinity? That's the left side of our graph. Oh, right. We have no idea. Because what would happen? I go to my left side of my graph. Is there any graph there?
X isn't approaching -infinity.
Yes. So two kind of different ways you could express this. This is option 1. As x goes to -infinity, you could say, hey, There's nothing there. Or, this is option 2, which I'm going to write in blue. You could say as, it's talking about the end behavior, meaning what's as far left as I can go? 1. So I could also say as x approaches 1, where's my function going to? So, yes, I go to -3. So,
Yo, what?
what? So you could either say for your left side, version on the black or version on the blue, whatever your preference is. But for the right side, everybody should have as x approaches infinity. Where am I going on my right side?
Infinity.
Yep, this will keep going up to infinity. What questions do you guys have here? All right, let's look at our next example. What type of function was this called again?
Cube root.
Cube root. So go ahead, take 2 minutes to think. Oops. You're gonna go through and jot down any ideas you have. So, like if you feel good about the domain and range, do that. But if you're like, I'm not sure about increasing, decreasing, well, we're gonna go through it together. All right, everybody.
Wait, can you give us a little bit longer, please?
Yes.
Thank you.
If you don't have it all done, it's okay too. We're gonna talk it through. All right, let's hear from you guys in that back corner table over there. What are you guys thinking for the domain?
Negative infinity to infinity.
Good job. You're gonna go left and right forever. What about you guys in that front table near my desk? What do you think for the range?
Negative infinity, infinity.
Good. All right, increasing, decrease. We're gonna walk through those together. Those should be the trickiest. So let's just first distinguish where what is happening. So when we start our graph, what's happening first?
It's increasing negative infinity to negative 1.2-ish.
All right, hold on tight for a sec. Now, after that, we're decreasing, and then one more time increasing. So if you're having a hard time with increasing and decreasing, getting like 2 different colored pencils, highlighters, those can kind of help you like mark through your graph of what's happening where. And then you can take like a pencil or pen, whatever you have, and you can kind of like mark your points where you're turning, right? Those turning points on your graph. So, and remember when you mark with a vertical line, it's going to help you know you should drop down to use those x values on your x-axis. So let's go first through your increasing intervals. So go left to right, so you always will go in ascending order. Helio, is that?
Yeah, can I just go back and use?
Yes. Did you do EHOPS and then graph it up? Did you do?
I want to ask you a
Let's hear it. Yes.
Is it like negative 0.8? Oh, that's not right.
We're
Oh.
increasing first.
Oh, increasing first?
Yeah, so where are we increasing?
Oh, one. Wait. Yeah, 1.5. Wait, is it not?
You're getting there. So remember, you go if you go left to right, you're gonna automatically write it in ascending order. So Jaden's like working through it, and I feel like everybody's like understanding where he's going of trying to say where you're increasing to. But if you go from the left, we're gonna write your interval correctly. Meaning, if I start all the way on the left here, I have my arrow, which means I'm increasing from where?
Negative infinity.
Yeah, good. So starting from negative infinity until we're increasing until here, which means what value? Yeah, watch is round, call it -1. Remember, parentheses, and there's another one, right? I heard someone say like, oh, there's 2, right? So if there's another one, what do I have to use in between them? The U for union, like there's another one, and it's gonna start at what x value?
1.5.
Yep. 1.5, and I'm gonna increase. Yes, remember I'm increasing. I'm not talking about going up. Like going up is increasing, yes, but it's like as I move to the right. All right, let's decrease next. So think about decreasing is gonna happen along the red, which means I'm gonna start where?
-1.
Yep, -1, and I'm decreasing until here, which is 1.5. Now let's look at my intercepts next. Let's hear from you guys in the middle back table. What are some intercepts we have? Yep.
0,
Yep.
1,
Uh-huh.
and 0.
Yes. Alright, good job. So remember, don't have to say these are the X, these are the Y, just list them out, and as long as you write your point correctly, you're good to go. Let's talk about our extremas. What do you guys in the front middle table think for extremas?
And the relative maximum of -1 and 6, and the relative minimum of 1.5 to -0.
And you guys said relative minimum?
Yes.
At, said 1.5. What are you saying for the Y value? -1?
Negative 0.8. Put negative 0.6.
Once again, anywhere close.
Like negative 0.6.
Anywhere close is good. What do you guys think up here? Are we confused? Yes, no?
Yes.
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 Yes, yes. Now we want to find an f of x equals 0. What does that mean? F of x equals 0.
The Y is 0.
The y is 0. So if my y value is 0, what places graphically is that asking you to list? Where's your y 0?
Oh, the whole X.
The whole x-axis. So basically, this is just a fun way to say, hey, what are your x-intercepts? So we have more than one value that's going to work here. So we're just going to list out those x values. So what x values do we have that make your output y equal to 0? What do you suggest?
-2.
-2?
And 1.
1 and 2. Great. So, last behavior, as x approaches negative infinity, what do you guys think over near the door? As x approaches negative infinity, where's your function going? So negative infinity, on my x means the left side, and where are we going? Down, so that means negative infinity. As x approaches positive infinity, so on the right side, where's our function going? Yep, we're going up, so you're going to positive infinity. What questions do you guys hear with the polynomial?
How would you like to write out the polynomial functions in comparison to like?
That is what we're going to do in January. So sit tight. What other questions do you guys have? But polynomial functions are anything above a degree of 2. So like x cubed, x to the, so this is a x, this function has an x to the power of 3, for example. So it's like x to the power of 3, x to the power of 4, x to the power of 5, yada yada. All right, you guys, look at our next polynomial and start working on it. All right, guys, let's do it. We're gonna start with you guys near my desk. What do you think for the domain?
Negative infinity.
Yes, good. Negative infinity to infinity. You're gonna go all the way to the left, all the way to the right. What about you guys behind them? What is our range?
Negative infinity to 1.5.
That looks good. What do you have with 1.5?
Close bracket.
Great job. Increasing, decreasing. I'm gonna go through that again. So what's our function doing first?
Increasing.
Increasing and then decreasing and then increasing again. Boop, boop, And then decreasing one more time. So as you can look and see, we're going to have two intervals for both increasing and both decreasing. So if you need to kind of get that double, to get the two different highlighters, two different pens, it can be helpful to be like, okay, I know I should at least be having two intervals for each, right? Two different places where you're increasing and decreasing. So let's talk about increasing first. Where do we start increasing?
Negative infinity.
Good, all the way from the left, and then we'll go into what value?
Negative 1.
Great. Now, let's go to my second increasing interval, which is starting where?
0.
Sure, let's use 0. Close enough for me. And then we'll increase until when?
1.5.
Yeah, good. Remember, drop down here.
I put 1.67.
That's fine. Like I said, not picky.
Oh my god.
There are bigger,
That is not-
there are bigger,
That's it.
get out. There are bigger issues in life than being super picky about the decimals. So let's decrease next, everybody. Where is our starting decrease interval?
Negative 1.
Yeah, good. Remember, it should be from least to greatest. So negative 1 until 0. And then we have to decrease again, starting here, which is what value?
1.5.
And then we'll decrease until?
Negative infinity.
Yeah, so, but listen, going down is decreasing. We are decreasing all the way to the right, which means infinity.
What about the negative?
No, positive infinity, because you're going to the right. All right. Let's hear from you guys in the front middle table. Where are the intercepts here?
Negative 1 and 0.
What else do you have?
Negative 2.
Other way around, 0.
0,
Negative 2. Hey, you guys, please stop. Thank you.
1, 0.
There you go. All right, guys, so once again, intercepts, list them out, comma in between, not a union. And then let's hear from you guys in the back middle table. What are some extremists we have? Yeah, absolute maximum.
Very instructive.
Do you guys have another one? Go to local max. And what else do we have?
Well, there's a lot of extremes.
Yeah, good. This would be a local minimum here. Yep, good. 0, negative 2. And then what do you guys think in the back table near the door? Are we continuous? Yes or no? Yes. And we want to find f of 0. So that means your x value is 0. What's the output when the x value is 0? Yep. Negative 2. And then your in behavior, as x approaches negative infinity, we're looking at the left side of our graph. Where are we going?
Negative infinity.
Good job. As x approaches positive infinity, on our right side, where are we going? Good, good. So, polynomial functions. What questions do you guys have here? Similar-ish to quadratic, just more curves and extremes going on. What questions do you guys have before we get into our piecewise functions? So piecewise functions, everybody, don't be intimidated by them. They sound and what they are, like their name, piecewise, meaning piece. You got functions kind of pieced all together on a graph. With that being said, just stick with your, your foundations, right? Domain, always go left to right. Range, bottom to top. So does everybody see how this kind of has 3 different pieces chunked together on your grid?
Yeah.
That's a piecewise function. We're going to do a lot more work with it next week. for today, we're just going to go through our characteristics. So, if you were jotting down that graph, it's the same one here. The domain and range are kind of tough here. If you want to go through, see what you can do. If you want to skip domain and range, we'll go through all of them together, but just kind of see what you could do on your own first. All right, you guys, let's talk about this one. So, I said domain and range are going to be the trickiest here. So, stick with your foundation. Domain means you're going to look from where to where?
Left to right.
Left to right. So, if you start all the way on the left, what do we have going on here?
Negative infinity.
Yeah, you're going left to right. So, negative infinity. And then,
7.
whoa, be careful, everybody. You're going to travel along towards the right, and here's the biggest, like, what's going on here first. Here's 2. I get all the way up to 2 with an open circle, meaning I'm including all my values right up until 2, and then look up. Oh, I do include 2. And then I have another open circle on top of it, and then I can keep going after 2. So basically, what just happened? Follow along. Think about it on a number line. I'm coming from the left. I'm coming from the left. I have all the values all the way up until 2. And then it's like, oh yes, but I got 2 up here. So I got everything as close to 2 as I possibly can, like 1.99999, whatever it must have been. And then it was like, boom, I got 2 up here. And then I came in from the other side, and it was right after 2, as close as you can get to right after 2. And then you kept moving along. So what does that mean? You can continue on with your domain because you get all the way up to 2. You include 2, and then you jump up here, but you're still including the values right after 2 all the way until this x value here of
7. Or am I wrong?
6.
Yes.
With a bracket. Did you have a question? So, are you guys, 1 second, we're not done. Focus back in. Big idea, everybody. Perk up your ears. When you have an open circle on top of a closed circle, like if you're doing domain, meaning you, like they're on top of each other, or if you're doing the range side by side, your closed circle kind of always trumps over the open circle because it'll say like, hey, you include a value here. So you can get all the way up close to it, and then you can include a value with it. So let's do your range. Where would you're going bottom to the top. So starting at the bottom, where's your first value you have for your y?
0.
0 with a
Open
bracket.
bracket.
Right, because we do include it. Now, go up to the top. Here's the first place where things are a little crazy. I have an open circle, but what do I have with it? A closed circle and the function value over here, meaning if I'm thinking about what's going on here, this is 4. If I would just say like find like your values when your y is 4, you could be like, oh, here I have y values of 4. So you can keep moving up forward, and then you get up here, and you have the open circle next to this value over here. Same thing. You're like, oh, I do have y values here, so I can keep going. So it'll go all the way up until what? Infinity.
Oh.
So let's do increasing. So our function's going to be increasing from here to here. So what is that interval? What's our first x value that it starts increasing?
0.
I was gonna get
0,
10, but it's
and we're always with the parenthesis, and we'll increase until 2.
Wait.
Yep, x. Decreasing, where do we first start decreasing?
negative infinity.
Good, all the way on the left from negative infinity until when?
0.
0, and then do we decrease more?
No.
Yeah,
Yes.
one other spot, right? So from here to here, which means what x value do you start?
2,
And then you decrease all the way until
6.
6. With parentheses. What do we think? Do we have any intercepts?
0, 0.
0, 0. Do we have any extremas?
I mean,
Oh,
there's
0.
relative.
Yeah,
0, 0. How would you describe 0, 0?
As a
Absolute minimum.
Absolute minimum. Now, are we continuous, yes or no?
No,
Why are we not continuous?
because there's pieces. Like,
There's pieces, right? Meaning, if you were to trace over your graph, you get to here, you have to pick up your pencil to keep tracing it. Now find f of 2. So what does that mean? If I want to find f of 2, what value do we know?
no.
We know x is 2. So if I go to where's x2? Here. Now stand up to your graph. Oh, I have an open circle. So can I have any values here?
Yes.
No, not with the open circle. It doesn't include it. But look, if I keep going, I have
6.
6. That includes it because it's a closed circle. Would I be able to include this guy up here? Nope, so it's just going to equal 6.
If there weren't like other pieces directly above it, and it was just an open circle, and like, what would you say?
Love that question. So Yusra's asking, let's imagine that this filled in circle was not here. Same question, right? You have 2 open circles. Would you ever obtain a value of f of 2? No, so you could say undefined or
NA.
NA. Either or is fine. Now let's find f of x equals 4. What does that mean?
Y is 4.
Y is 4. So if I go to where y is 4 here, here's where y is 4. So kind of think about all along this line is what I'm looking for. So what values are equal, or what values for x do I have when my y is 4?
0.
I have -2. I have -2 right here. Good. Would I be able to include this open circle here? No, but I can also include this closed circle here, which means x is also 6. And lastly, as x approaches negative infinity, where's our function going?
infinity.
Infinity! Up, up. Oh, so I have as x approaches positive infinity, where's our function going?
NA.
Yeah, there's nothing going on the right, so option 1 is writing NA with that, or option 2, if you remember, could be saying as x.
approaches 6, f of x approaches 4.
Yeah, good. As x approaches 6, f of x approaches 4.
Oh.
That would be as far right as you can go.
But we could just put NA.
Sure.
Yeah.
Can I use the restroom?
Yes. What other questions do you guys have? We're going to have you guys try one on your own. Here's what we're going to do. While you're trying one on your own, I'm going to pass out the classwork. If I were you, in addition to writing your name, also do 9-3 on your classwork with, I'm going to have you guys try one on your own. I'm going to just put up the solutions after like 3-ish minutes. And then you're going to check if you missed somewhere along the way. If you're unsure, you're going to ask me, ask a neighbor. And then from there, you can get started on the activity. So we have 6 countries of graphs. You're going to go around the world, aka around our classroom, and do the characteristics for each of them. I have clipboards you're welcome to use. They're also posted on Schoology too. But you have plenty of time in class today, and you have time next time. But like after those 2, if you still need more time, they're on Schoology. Jaden, what was your other question?
You answered it.
Thought that might have happened. What other things? All right, so here is our example for you guys to try.
It's